A bit experimental. Basically read a blog post by one of Twitter's prior engineers, and he discussed this notion of like a code reading club, and I liked it, so that's what we're going to do here. First off, if anyone gets bored or annoyed, feel free to go away. I'm not going to be bothered by it. Second, if this does work out, I'm hoping that you're going to come up with ideas for content for later meets in the same format. And finally, if you want to run one of these, one of these experiments, then feel free. Like, I don't want to be the only one doing it. The idea is to take a piece of code from, either Wix code, an open source library, really whatever, in any language, and just show some interesting stuff. Okay, point out good code, bad code, crappy code, anything that you can think of that might be of interest to engineers. In this case, because it's all ad hoc and I didn't really have any time to plan, I was also asked not to do it in Scala, because there was supposed to be a Scala track running concurrently with this one. So I chose a bit of Java code, because that's the other thing I'm familiar with, and ended up going with Google Guava, the Google library. Is anyone here not at all familiar with Guava? Okay, 2 people, 3 people, whatever.
In Hebrew it's Guava, in English it's Guava.
I don't know, I'm gonna call it Guava. So anyway, there's, it's basically an Apache Commons written by Google, okay? So it's a bunch of like utility functions, utility classes, a whole slew of code that's supposed to make your life writing Java code better. So I'm going to focus on a very small subset of it. Specifically, I'm going to talk about listenable futures, which is, for those of you who have worked with like futures in Scala, the basic construct shouldn't be surprising. And hopefully we can, maybe learn something. So let's get started. If you have, this is ideally interactive, right? So if you have any questions or you want to refocus on something or whatever, just, stop me. So what I have here is does it show? Right. Is the source code for Guava open on IntelliJ. And there's a whole slew of things here, but what we're really interested in is listenable futures. So this is what we're going to start with. Now I'm going to bore you for a couple seconds while I open my notes here. Done. Right.
Can you zoom in a bit?
Yeah, I'm going to start by hopefully being able to increase the font size, which for some reason isn't working.
No, zoom in.
No, I'll zoom in, but zoom in doesn't change the font size, so it's, you zoom in on something that's too low res, it's going to suck. So let's start with increasing the font size to, say, 18. Come on, Git. Ah! Huh. Let's zoom in. Okay.
No, you can pinch in IntelliJ. You don't need to pinch in the Mac.
Yeah, but it doesn't.
Pinch out.
Nah, it should work, but it doesn't for some reason. I don't know why.
It's a Mac, so.
No, I tested it yesterday and it did work, so I don't know what's going on. But anyway, okay, so Listenable Future, that's like the entry point to our, to the subset of the library that we're going to be talking about. So obviously there's a package definition, specifically it's COM, Google, Common, Util, Concurrent, whatever. This is basically going to be our home for the next, however long we're going to spend on it, which is probably somewhere around 50 minutes to maybe more. We're going to skip the imports because they're not interesting. So let's first take a look at what a listenable future is. Essentially, to make a long story short, one of the concerns with futures in Java back in the day is that they're not composable at all. Like, you get a future is, a handle to some computation that's gonna happen somewhere, and at some point you're going to be able to get your result out of it. So it's analogous to promises in JavaScript and basically any modern language, modern platform, that is to say not Ruby, has it. And in Java they're really, really limited. So the idea behind listenable futures is that you get this interface, Listenable Future, of some type, right? You could get the result of your computation can be an integer, a Boolean, a data transfer object, whatever. So that's in this context, it's V, and it extends a future. Okay, so Listenable Future is not a first-class construct; it's an extension of the futures that we already had in Java, and it just adds this one. It adds this one method that maybe I can zoom on called addListener. And the intuition here is that when the feature completes, you want to be able to tack a callback onto that feature, or you want to be able to take the result of that computation, do something with it, and then whatever, continue the computation or pass it a callback so that you can process the result or anything of the sort. So what you give it is you give it a runnable, which in Java parlance is just a a method handle. Okay, it's an interface that has just the one method that says run. So you give it something that runs in the future, and an executor, which is the abstraction in Java that traps either a thread pool or whatever, some sort of asynchronous execution context, which you need to have. So what I'm basically saying is I have this computation that's going to return in the future. I'm tacking on something that needs to happen when that computation completes, and here's where it's going to run. And I control where that happens. So that's addListener, and that's all there is to a listenable future in a nutshell. To the interface, okay, we haven't started discussing the implementation. Before we actually get to the implementation, one of the things that I want to point out already in this context is, this is JavaDoc. So for those of you who don't do Java, this might look, weird, but essentially it's inline documentation, and you can do all sorts of stuff like have hyperlinks to classes. So say this is a feature that accepts completion listeners, blah, 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 blah. And then future, okay, this is how it's rendered to HTML. A feature becomes a hyperlink that takes me to the future class. So the first thing I want to point out is just how really sound this documentation is. Okay, this is just the entry point to a library. This is just one interface with one method, but it brings with it a whole slew of patterns of use. Okay, the interface itself is useless. Like, when should you use it? Should you return that interface from your own service methods, or should you how do you implement it? What are the right patterns that you should be using? So the documentation is really good. I mean, we get a feature that accepts completion listeners. Each listener is an associated executor, yada yada yada. It has this whole section about what the purpose, what the rationale behind having these listenable features is. It has sample code. Okay, this is pretty trivial sample code. So just to give you a bit of context, here's how you would use one of these. You have this service that you query. Okay, you run a query on a service, you get a listenable feature. And then you want to do something when that computation completes. So you add a listener, and you give it a runnable, and that runnable does something. In this case, it increases the number of processed items. It removes your query from a list of pending queries that you have somewhere. It logs stuff. All of this happens when the feature is complete, and once this listener is registered, you can basically return control to whatever it is that ran your code, and have them continue as if nothing happened. So this is just one example of what great or at least really good library documentation looks like. More importantly, it also gives you a whole section about, how do you get an instance of this thing, right? You have an interface, brilliant. Are you expected to implement it on your own? Do you have a library that's backing you, that tells you what to do or how to make use of it? And it really gives you a rationale for it. It says developers are encouraged to return listenable features from their methods so that users can take advantage of utilities built atop that class. And it goes right in to say that the way they will create listenable future instances depends on how they currently create the futures. So they give you these different use cases that you're likely to start off with. Like, you don't use futures in a vacuum. You have a service or you have a computation. You want to do it asynchronously. You want to run it on a thread pool. Okay, in our case, for instance, at Wix, we have this whole notion of an RPC system. You run an RPC call on an external service. You could, hypothetically, because we don't support it because we kind of suck, you could hypothetically do it in an asynchronous way. You could run an asynchronous HTTP call and get a callback once that call completes on the server side, and then do something with it. Okay, so a listenable future could be used to provide a callback. So in that context, we'd probably have this, we'd have this executor, this thread pool, or this Netty or NIO substrate that we're running our services on top of, our HTTP calls on top of, and we're starting off with a future. Now, what we'd like to do is we'd like to provide our users with a listenable or completable future. So they really go to great length to give you, all the context that you could need to sort of find your way through the library. And probably the most crucial point in this documentation is this. Custom executors may find it more convenient to use listenable future tasks directly. Or if you already have an executor service, you can decorate it with more executors.listening decorator. And then you get a listening executor service, which gives you back listenable futures. So this is this is where we actually start digging into the library and the implementation to find out, how it works. Any questions so far, or any comments? Yar?
Maybe I'm missing something, but this interface doesn't allow you to act upon the result of the future. Because you pass in a runnable.
On the one hand, you're correct, or at least it might seem that way, but when you're adding a listener to a future, that means that you have, by definition, that future already, because that's the feature you're adding a listener to. So typically what happens is you close over that feature, as in, a closure, a lambda.
Then you have to explicitly do future.get.
Yeah, I'm not saying this is the most modern way you could work. I mean, this is Java. Yeah, this is Java, okay?
We really have a good documentation.
There is no...
We should get their technical right.
Look, there is no abstract concept of a first-class function in Java. Like in Scala, you get a function one. You can define a function that takes a certain parameter, returns a certain result. Yeah, you don't have that...
They could have accepted, instead of runnable, something that gets the...
They could. This brings us to something that we'll probably come back to during our investigation of this code base, is that some of the design decisions are not rationalized in comments or in documentation. So you can only make educated guesses about why that is. In this case, my best guess would be that the reason why add listener accepts a runnable and not a specialized interface that takes a type parameter, takes a parameter of that type parameter, yada yada yada, is they wanted to keep the surface area very, very small. Like, this is an extension to the Java Features library, so it wants to, like, the design goal is to reuse as much as possible of the pre-existing Java concurrent code, and they try to keep it the amount of classes, the amount of interfaces, the amount of new constructs that you need to know in order to use that extension to a bare minimum. That's my assumption, but it's a good
decision.
It's a decision, okay? Saying that it's a good or bad decision is a value judgment because it's an aesthetic preference, right? It's not something, nothing prevents you from getting to the result of the future. Maybe you don't even need it. Okay, so it's an aesthetic preference whether or not you actually add a specific interface to handle those callbacks. or you just use a runnable and close over the future. Either option is valid because it's going to work and it's not going to prevent you from doing anything. So it's really an aesthetic preference. Like I said, my guess is that it's to keep the library surface area as small as possible.
Yeah, you can think about it as like they're giving you their interface, so you can easily integrate it with your system without changing too many things. You don't have to build their interfaces. You already have a runnable because you did it in a thread pool or something, but you can actually use it as a feature now.
Well,
which makes
it's not likely that
a good decision.
it's not likely that you'd have had a runnable beforehand because this is a callback. You wouldn't have a callback if you didn't have the infrastructure to support callbacks, right? So you probably don't already have a runnable. But as I said, it's a value judgment. Like there is no right answer here. There is just design goals and decisions, and they're not documented. So that's the other thing I want to point out is while the documentation for the library is, at least in my opinion, pretty damn good, they haven't documented all of their design decisions in either comments or Java docs or whatever. So, we need to make educated guesses. Any other questions so far? Is the concept of a listenable future clear to everyone? Can we move on to the implementation? Cool. So, next up, I need to reopen my notes here. Because I'm an idiot. Right, next up is, let's talk about listenable future tasks. Okay, because that's what the documentation points us to. So we have this listenable future task, and is everything working there? Aviran?
The camera adds 4 pounds.
Well, the camera adds 4 pounds, and the shawarma I had for breakfast adds 40. So, right. So, let's move on. A listenable future task. Okay, so I'm going to assume some familiarity with Java util concurrent and this kind of stuff that it provides you. So if you don't know something and it's not obvious from the context, then just stop me and ask for clarifications. So a listenable future task is a future task that also implements the listenable future interface. That's basically it. So what's a future task? It's pretty simple. Essentially, a future task is a feature. It's part of the Java standard library. It's an extension of feature that also supports cancellation. Okay, it's essentially a state machine. Okay, a feature task can be in one of many states, and it's pretty well documented here what the states are. Okay, you instantiate a future task, then it can be, then it's running, and then it can be completing, and then the completion can be either a normal completion, by which I mean, this task has run, it's finished the calculation, and there's a result waiting. So that's a normal completion. Or it could have ran into an exception of, whatever sort, some kind of error, and it finished exceptionally. So you can grab that feature and get the exception out of it. So that's exceptional. Or it could be canceled, or it could be, it could have been interrupted, in which case it moves to the interrupting state and then finishes at the interrupted state. Now, the details of this aren't that important. It's just crucial to understand that a future task is, can be canceled and that there's a state machine behind it. Curiously enough, if you notice the to-do statement here right at the beginning of the class, it's not a final class. Okay, so it's a listenable future task is a construct that arguably can't change. Like it's a very limited construct, and you'd prefer, at least conceptually, you might prefer to limit, how it can be extended. That's not the case here. I haven't found any, they're giving one example of why this is not final and where it makes sense with the bounded queue executor service. I haven't actually delved into it, but it's a curiosity, like it's something to consider. So let's look at the implementation. We have an execution list. We're gonna deep dive into that in a second, but in a nutshell, it's just a it's a container that holds a list of listeners, and then you can use it to trigger those listeners. Okay, so I have a feature, I have a bunch of callbacks registered on it, and and they're kept in that state is kept in the execution list. We'll deep dive into it in a couple minutes. Another curiosity is that this class has no public constructor. Like, you can't directly instantiate a listenable future task. You can only use create, which is a factory method. It's a static method, or you could extend it. Once again, I haven't been able to find any kind of design rationale for it. No one seemed to have, like, I literally Googled, why is this thing not, doesn't have a public constructor? I couldn't find any user group explaining this, user group post or whatever.
Gives them more control.
It would have given them more control were the class either final or, or it can be extended. Like, it doesn't really give them more control. So I don't.
Sugar, because when you do listenable feature.create, you pass a callable of V, and you get a listenable future task of V, and you don't need to specify the V again.
Yeah, but you can do that in a constructor as well.
No, you can't.
In Java you can't?
No.
Well, Java sucks.
Java doesn't have type expiration in the.
Okay, so there you are. That's one possible explanation that I wasn't really aware of. So okay, so that might be the rationale behind it. There's two versions of create. One takes a runnable, or rather, one takes a callable, where callable is essentially a runnable. If you remember runnable, it has just one method called run. That's a void. It doesn't return a value. And a callable is like a runnable, except it does return some value. Okay, it has one method. It's called, I think, call, and it returns a v. So this is really kind of what you'd expect. Okay, that's like I'm creating a listenable future. I'm giving it some code to be executed somewhere in the future, asynchronously, etc. That piece of code returns the value. That's the value of the listenable future. That's the commonplace use case. The other version is more akin to a convenience factory method. It takes a runnable and a result. And the intuition here is if you have a piece of code that does not necessarily, it doesn't necessarily return a value, but you want the listenable feature to return a value, like a success marker or something derived from a thread local state or anything of the sort, then you can, well, that last bit with the thread local state won't actually work, because what it takes is it takes a runnable and a result. And if the runnable completes properly, the result of the listenable feature is going to be that, that V that we gave it. Whereas if it fails exceptionally, then the result is going to be the exception, and this result item is basically lost to vacuum. So these are really the two kind of options that you have in creating a listenable feature. And these are package protected constructors that the create methods actually use. And maybe now we know why this distinction between factory methods and constructors. Moving on. Add listener and done are actually really dead simple implementations. Add listener takes a runnable and an executor. That's the listenable future interface that we've already seen. It goes to the execution list and it just adds the listener and its corresponding executor. Okay, so the actual logic that implements the callbacks is encapsulated within the execution list, which we'll get to in a second. The other thing that happens is that feature task has a method called done that gets called, like as I mentioned before, a feature task is a state machine. When it moves to the completed state successfully, done gets called. Okay, and when it happens exceptionally, actually, done gets called as well. So when the feature completes, there's a state transition in the class this thing derives from, and then it just triggers all of the listeners. Now, the curious thing about it is, the other thing I want to point out is you'd expect, like, this whole thing is an abstraction with the goal of making it really simple to tack on some sort of executable bit of code after a feature completes. So what you'd kind of expect is, considering the way this is constructed, you'd expect this to be marked as final. Like you'd expect the class hierarchy to be constructed in such a way that even if you, for some reason, derive from listenable future task, which, tying back to our earlier comment, really hardly makes sense. There are maybe some use cases that the people actually working on this library could conceive. I really can't. Okay, but if you derive from this thing, you can also wreak havoc by overriding done. Like you could basically take a listenable future task and make it an unlistenable future task by breaking this bit of abstraction. So there's a final keyword missing here, and once again I couldn't find any rationalization behind it. So it's one thing to consider when you're.
Moreover, it says in the Java doc,
internal implementation
that it doesn't allow overriding done.
I don't remember it saying that it's not actually allowed. Does not provide an overridable method. Okay, so that's also inconsistent with the documentation, which is kind of a shame. Obviously, if you're actually considering doing this, and you're probably going to be looking at the superclass, which is this thing, and you're going to be looking at the documentation, and you're going to be seeing something like internal implementation detail used to blah blah blah. So that should raise a freaking huge red flag over your head that says, this is an implementation detail. You don't get this. Right? You shouldn't touch this unless you know exactly what you're doing, which you probably don't. Okay, so.
And the people that will do that probably will ignore that as well.
Whoa, probably. So as far as library construction is concerned, this is weird. Like, I don't know why it's not marked as final. I don't know why it's not limited. I couldn't think of a good reason, and I wanted to point it out because it's curious. Okay. So any questions about this, this basic thing called listenable future task? This is like the rudimentary implementation of a listenable future. Okay, let's move on to what the execution list is. Okay, so this is supposedly an implementation detail, but I think it's an interesting class to look at. So it's special purpose. One interesting thing is that it's a public class. There's no really good reason to make it private. It's special purpose, but maybe someone can reuse the functionality. But I don't know. In my view, it's kind of an implementation detail. So were this my library, I'd probably make this a package visible class. So let's take a look at what it does. First of all, it uses Java util logging for something. Okay, there's a logger here, which is already curious. Do ignore, there's a couple annotations here, visible for testing and guarded by. These are JSR 305 annotations. You shouldn't really bother with them, okay? We're not gonna go into them. The important thing is that the state that it maintains is really two things. There's a runnable executor pair, which, as I'll show you in a second, is basically a linked list of pairs of runnables and their executors. Like you get, when someone calls an add listener, you're provided with a runnable, which is the actual callback or continuation code, and the executor that it's supposed to execute on, so that's a pair. Runnable executor pair is not just that pair, it's also a linked list of these pairs. So that's the state. This is the list of actual continuations. And then there's a flag, Boolean execute, which is pretty brain dead. There is a public constructor, which doesn't really do much, and this is where things get interesting. So we have this add method, which is what the future task, listenable future task that we just looked at used. It used add and it used, execute, or I think it was execute. So add is just the public interface that actually takes a runnable and executor and deals with them. Now this is where things get a bit curious, because if we take a look at the documentation, then the first line is pretty crucial, right? It adds the runnable and accompanying executor to the list of listeners to execute. This is what you'd expect. But there are caveats to that. So one thing to consider is what happens if I have a listenable future and I registered listeners on it. Okay, I register callbacks, but this listenable future happens somewhere else, right? It happens in an asynchronous context. So it's possible that it's already completed before I've added my listeners. So what happens then? The way this library resolves that is, this part of the sentence. If execution has already begun, the listener is executed immediately. And this is actually kind of a misnomer because I'm not sure if it's true that it does that if execution has already begun. I think it's more like if it's already completed. It's a subtle distinction. I've only just noticed it looking at it right now, so I don't have any good answers as to, whether it actually happens when it's begun or when it's completed. It's a crucial point because consider what's the difference? Okay, I have this future. It's happening. I have this callback. Okay, this callback, if the callback executes while the future is still not complete, then to get at the value of the future, I do a future.get, and that's a blocking operation. So if this precise wording is actually correct, and that callback can happen while the execution of the future has begun but not completed yet, I could theoretically block the thread actually running my callback in certain cases. Okay.
Does it get blocked or it throws an exception?
It blocks. Okay, so I'm pretty sure this is actually inaccurate, and it should be if execution has already completed, the listener is executed immediately. I could be wrong on that, so that's something to consider. And it also, it also makes a good point of just how critical it is to be precise in documentation when you're actually coding a library. Okay, because it's just one word. Execution has started, execution has completed. It's a pretty subtle difference, but it means, it could have massive ramifications to how the code base around your library is actually constructed. Right. So, there's a note here that says for fast, lightweight listeners, yada, 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 yada. Crucially, there's a bunch of comments here that are not actually crucial. But one thing that we're going to run into, or maybe we've already covered and I forgot to point it out, is that there is no guarantee of the order in which callbacks run. Okay, so the documentation says this a number of times. I'm pretty sure it says that. Right here. Any runnable added after the call to execute is still guaranteed. There is no guarantee, however, that listeners will be executed in the order in which they are added, which is a really crucial point because A, it's going to give me some, it's going to give me some meat for discussion later, and B, because it's something that you need to consider if you're working with these listenable features. So, going back to the implementation, there's...
Say why they chose to do that.
It's a design constraint. Like if you want to guarantee the ordering in which callbacks run, then it matters. There's a number of things that you'd have to consider, and the first is when a callback is registered, it's registered as a block of code and the executor on which it's run, then that means that by definition, the ordering in which things happen is non-deterministic because it depends on which specific executors you provided when registering the callback. So if that executor actually has a thread pool and it's bounded and yada, 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 then there are literally no guarantees of ordering. You can only guarantee the order of submission to those executors, and that's kind of meaningless. So, right. First thing we do is we run a couple of preconditions. Okay, the runnable cannot be null, the executor cannot be null, that's crap. Second thing we do is we synchronize on this. Like we grab a monitor on this. We check if this execution list has already been executed, by which I mean the future that uses this execution list has already completed. Then there's two options. Either the future is completed or it hasn't. If it hasn't completed, we want to register a callback. If it has completed, we want to invoke that callback right away, because that's the guarantee that we made, in the API documentation. So,
Is it also guarded by this lock?
well, yeah, it's within the same scope.
Other places where you can change it.
It's a private member of this class. So whenever,
It's guarded by this.
and it's guarded by this, which is just an assertion. But anyway, to your question, yes, but you'll also see all the places where it's actually in use. So if it's executed, if the future has not already completed, we take our runnable and our executor and we create a runnable executor pair, which is a stupid class that has a runnable field, an executor field, and a next field, which, as I mentioned before, this is basically a linked list, and we just prepend to it. Okay, we grab the current list, we build a new link that that links, okay, that attaches to our pre-existing list, and then we replace our whole list with that new item. So this is the entire class, and this is what we do here. Okay, we take our list of current runnables, which starts off as null, and we add a runnable and executor pair to it, and then we just replace runnables with the new linked list.
Also, the name
And return.
is so confusing. Runnable executor pair.
Yeah, it's not. I mentioned it before. Like, the runnable executor pair is indeed a runnable executor pair. What they forgot to mention is that this class also constitutes a linked list of runnable executor pairs. Yeah. So exactly. The other question is, why not just use an array list or whatever the hell? So really, what they'd have wanted to use is probably some sort of array list would be inefficient, because array list, you add to an array list, right? It doesn't have a semantic, at least in Java as far as I can remember, it doesn't have semantically a prepend method. And to add to a linked list, at the end of it, to append to a linked list, you have to traverse the whole list, find the last bit, then modify it. So it's much quicker and simpler in a thread-safe concept to prepend. Sorry?
Java linked list, you can add. You can do it.
You can. I think it's insert at index 0, whatever. I don't know why they necessarily picked this method. I think that, considering just how simple this code is, the naming sucks, right? But the implementation is trivial, and it's really, really, really fast. So I think in this context, it might have made more sense than to actually create this, big general purpose container that's based on a linked list and adding stuff to it. It's this is performance sensitive code, at least up to a point. So you don't want to waste CPU cycles doing, useless stuff. So this is a design goal that, once again, they have not made explicit. Like, there is no comment here that says here's why we did this, which is kind of a shame. But there are reasons for it, and performance and small objects and all that stuff, and simple APIs make sense because it's on the same class. Like, it's a very limited scope of functionality. So it's curious that they did not use array list or whatnot, but it does make a certain amount of sense.
It handles very elegantly, from my point of view, the lazy initialization of this data structure, because it is initialized as null, and null fits well for the last element in the linked list.
Yeah,
you don't have to initialize and check whether you have already.
True that. If you've
another interesting thing here.
Yeah.
And it's something that you repeated several times.
Have I?
They have very good documentation, very comprehensive documentation, and they explain why they do stuff. But they do not explain why they designed this. They designed the library this way, why they chose this specific implementation. And this is one problem with documentation in general.
Yeah.
That you have actually three types of documentation. There is the trivial documentation, which is int number of puppies /
Yeah,
copies.
there's the public surface area. There's like the signature of the stuff that you have in your library.
Then you have the
Java docs.
this sort of documentation which explains why we did this specific thing, which is good, okay? Because you want to know why we want to fail fast on NALs, but they are missing the most important form of documentation, which would actually help someone understand 1 year later what was the thought process that led to the development and the implementation of this.
Yeah, but adding more documentation to that class, I think that will be.
Okay, I'm gonna stop you there because that's, once again, we're getting into value judgment territory. But I would say that A, you're right, and B, that problem is actually hugely commonplace. Like the amount of, I don't know if any of you is like, I don't know how many of you have seriously dug deep into any open source or even closed source, but you know, where you actually have the source projects. But this is almost always what happens. Like you have the public surface area, which, you know, code is documentation, so you can't get it wrong. You have the comments, which can be good or can be, you know, missing. But almost no one has like a cohesive, some sort of cohesive source of truth for the rationale behind their design choices. And if they do, it's typically external to the code base. It's usually on a wiki or a website, or, you know, encoded in, you know, included in talks given at conferences and that sort of thing. It's always ad hoc. And there really isn't a good general purpose solution to this problem that I'm aware of, but it's something to take into account when you write your own code. So moving on. Okay, we have this linked list, which, if you've noticed, is actually implemented in the exact same way as Scala's list, immutable lists with their prepend semantics. Right. So if we haven't completed yet, we just update the linked list of registered callbacks and, you know, move out. Now here's a curious little thing. First off, if we've already completed the feature, then we just execute the listener, and we'll get back to execute listener in a bit. But what's crucial here is actually the execute method, which is what the Listenable Future calls. Like, this is how the Listenable Future actually completes and then triggers all your, all your registered callbacks. So, a few things about the documentation. This method is idempotent. Calling it several times in parallel is semantically equivalent to yada yada yada. They've reiterated what idempotence is, which is kind of wasteful. Crucially, however, note that listeners added after this point may be executed before those previously added, and note that the execution order of all listeners is ultimately chosen by the implementations of supplied executors, which is what we just discussed before. Like, if you're submitting your callbacks to executors, you can guarantee the order of submission, but you can't guarantee the order of execution, because it's asynchronous by design. Also interesting is that once execute happens, once the feature is completed, execute is idempotent, but it actually only runs the registered callbacks once. And what takes care of calling subsequent registrations, okay, taking subsequent registrations of callbacks and actually executing them on the spot, is the add listener, which we've seen. Okay, it's this thing. Add listener has this if statement, and if we've already completed it, just executes the listener. So that's not the responsibility of the execute method. And here's how it's implemented. It synchronizes on this. If we've already executed, this is the guard, okay, then we're done. This is what guarantees idempotence. If we're executing, or rather we're completing the feature for the first time, we're marking the flag as true. We're taking the list of runnables, and this is a curiosity. We're taking the list of runnables, we're setting it aside, and we're nulling, we're marking the list of runnables that we already have as null. And this is, I'm not sure this actually...
This is not true.
What isn't true?
This won't allow the digit to free anything.
It will once this method completes, because then the runnables are outside of scope and they're not referred to from this class anymore.
Yeah,
so
then just null it in the end.
because you need to null it inside a synchronization block, and you don't want to keep the synchronization in place. So the real question here is, why null it at all? Like, is this interesting?
This is a VB programmer. Probably.
I don't think so, considering.
Also,
Okay.
Look at the comment.
Seriously though,
Free listeners,
even if this stays,
around for a while. What
yeah.
is this?
So this is pretty vaguely documented, but one possibility is that, I don't know if this was here from day one or they've added it at some point. One possible rationale for this is, if you have a whole slew of these callbacks, you submit them sequentially. They may run asynchronously, but you submit them sequentially. So it's theoretically possible that this execute method actually takes quite a while to complete. Because if you give it a whole bunch of runnables and they're running on, say, direct executor, and they're running in line, it could theoretically be that this execute method takes, any number of milliseconds, seconds, whatever to complete. Hold on that just 1 second. Let me finish the thought. So this could be, it could be argued that this is premature optimization. I haven't dug deep enough into the submission logs, the subversion logs, whatever, to actually know whether this was here from square one or not. But there are, it could be rationalized. I'm just not sure if I've ever written code that does this, ever, in any context. So it's curious. You were saying?
I think that the runnable is a member of what? The Listenable Future?
No, runnables is a member of execution list, which is the class we're currently looking at, which a listenable future task composes.
Because from what he wrote, I think he thinks that people can store that instance without actually GCing that instance. And this way, if they're keeping that instance in their code, then you force the runnable section to be GC. But
it doesn't. You never force anything to be GC'd. You enable it to be GC'd. Like I said, it's a curiosity. Okay, I don't know what the right rationalization for this is, but I can see, like, this is harmless. Okay, logically this is harmless, and there might be good reasons for it, but it's curious. So that's why I pointed it out. So here,
one of the issues with listeners, because they point back, so sometimes the whole graph object
remains alive.
Memory doesn't free itself, and you have to disconnect the graph somehow.
No, you can never have a closed graph like that, I think, but
no, if you put a listener and you store it in some static.
Well, in that case, obviously, it's never going to be freed, but that's because the user of the library screwed up. But anyway, okay, it's a curiosity. Let's move on. We can probably talk about this for another hour for no reason at all. So the other curiosity here, which I think is way, way, way weirder, is that we take the list of runnables, we put it aside, we have this list of runnables. The next thing this code base does is it actually reverses the order of the list. So when registering, we prepend to a linked list, which means that we're essentially maintaining our list of listeners in reverse order at any given time. So what this does is it takes it and reverses it so that they can be replayed in the order in which they were registered. And the question is, why the fuck bother? Like, the whole API documentation mentions numerous times that they may be executed out of order. So why bother, submitting them in anything that resembles the original order of registration? Who cares?
I think they even the condition in which it's not going to be replayed in the order that you said, after reversing, you'll get a call that adds another listener.
No, because at this point, once you get to this point, no new listeners will be added to the list. Executed is already true at this point, so whenever someone adds a listener, that listener is going to happen in line. Okay, it's going to be submitted right at that point. Okay, so it's safe, but it just makes no sense. Okay, so it's pretty quick because it's just reversing, we're reversing a linked list mutably in memory, so it's pretty fast. It's just pointless. I don't know why bother.
Originally, and not the runnable executable pair.
No, because you'd need, you'd need some memory structure that would be both efficient for traversal, efficient for appending. It's, I don't know.
It's a doubly linked list.
A doubly linked list or the queue or whatever. I guess the question is, if you don't care about the ordering by design, then why bother with this? I couldn't find any.
The guy cared. He cared, but he just doesn't commit.
They say it's to fulfill the contract, but what it says is, it's a bit inconsistent because the contract says, okay, these listeners are going to be. It says somewhere up there that the listeners are going to be executed in the order in which they were registered, but with certain constraints about our ability to provide these guarantees. So if you're not going to be providing the guarantees, why bother? Why bother making any sort of effort to be ordered? Who cares? So this is the one thing about this whole library that's just like why? But they did it anyway. So I wanted to point this out because this is really. The algorithm is sensible, this is pretty readable code, but just why is it even there? You need all this frickin' comment and this frickin' code. It's like 20 lines of comments and code to do something that no one cares about. So this is pretty bad.
This should have been extracted to a private method if it's needed, because
that's arguable, but it also doesn't matter. Like, I don't know. I wouldn't bother. Okay. It is arguable because once again, this is a value call. Like this is an aesthetic judgment. Should this be extracted to a private method or not? I don't know, because this whole class is pretty damn small, especially in Java world where things are really, really verbose, and also it doesn't have an abstraction of a linked list, right? It manages the state of the linked list explicitly in code everywhere. So should it try to abstract it away to a different method? That's arguable in my opinion.
What's the size of a method should be? Smaller than this. This is the law.
For any given this, you mean?
For any given this.
Yeah.
Smaller than this.
Okay. So I think we're all in agreement. I think that this is bullshit. Everything selected here is just bullshit code. So whether this bullshit code is inline in one method or extracted to another, it's still bullshit. So, right. Okay, so the next thing we do is we go over the reversed linked list. We execute the listener for every item in the list and move on to the next. So this is pretty straightforward.
I think it's pretty clear that this guy is a C programmer.
Yeah.
You need to take one thing into account, and that's, once again, this is pretty performance sensitive code. You want to avoid unnecessary allocations. You want to avoid unnecessary locking code, concurrent code, anything that you can avoid, you want to avoid, because this happens a lot. So whether or not this guy is a C programmer, I don't really care. I used to be one, and I'm perfectly sane.
It could be a gap, so let's not.
No, it's a guy. The narrative says it's a guy.
Okay, execute listener. Let's move on. Execute listener is essentially takes a runnable and an executor, and it just wraps it in a try catch. The thing is, these, you need to have some sort of semantics about what happens if a callback fails. And a callback can fail really in, it can fail in one of two ways. It can fail by throwing an exception that's an application exception. Okay, anything from a division by 0, say, is an application exception, right? Whereas a Stack Overflow exception or an out of memory exception or a holy shit, my kernel just broke exception, these are not application exception. These are errors. And Java actually makes the distinction in its built-in class hierarchy between application exceptions that you need to declare. These are everything that derives from exception, Application exceptions that you do not need to declare, these are runtime exceptions, things like null pointer exception, Stack Overflow, whatever. And things that are systemic exceptions, okay, that are virtual machine grade exceptions that you do not need to declare and probably you cannot handle applicatively. So these are things like out-of-memory error, okay? There is not much you can do with an out-of-memory error. It gets thrown so that there is some sort of cohesive execution pipeline going on. But you're not actually supposed to ever catch that kind of error. So you have exception, runtime exception, error, and throwable, and all of these construe like different variants of errors that can happen. So what this does is it traps the callback, and it says, okay, anything that's not a systemic error, anything that's up to a runtime exception, like a thrown exception or a runtime exception, I catch, I log, I throw away. Okay, there is nothing I can do about it, and the guarantee that I provide to my users is that if you have 5 callbacks registered on this listenable future, and one of them breaks for some reason, divides by 0, has a null pointer or whatever, I'm not going to stop the execution of the other 4. I'm still going to run them.
It's not the listener will call. It's the executor won't throw the exception here.
Come again?
If you have an issue with the runnable itself, you won't get that exception.
No. You need to make the distinction between the computation that we started off with and the continuations. Okay, the callbacks that I'm registering. Okay, this is about the callbacks. A callback could also fail. Okay.
I know, but I think the runnable here is something that contains the callable, but the exception will be thrown to the executor. No, it's not going to be thrown here.
That depends. If it's
unless it's an issue with the executor.
They said above that the command that you use direct execute. Now direct execute executes in the same thread.
They don't. They recommend in some cases. Okay, so yeah, there are really several. No, but it's a really good comment because there's actually a few places where this exception could be thrown. Okay, if the executor is asynchronous, like it has its little thread pool, then the executor managing that execution actually has semantics about what to do with unhandled exceptions. That's the unhandled exception handler, or whatever it's called. Okay, so that's one thing that could happen. But on the other hand, in some cases, it could be that the executor itself throws an exception or whatever. But all of this happens in the context of trying to submit a callback for execution. And if that fails for any reason, then we log it, unless it's a systemic reason, in which case we propagate it and the whole thing blows up. Okay, so if an out-of-memory exception happens, we blow up, and that's fine. That's the expected behavior. But it's a...
It's the listener, not the code itself. So if it was the code itself, it would probably have to execute the listener in a failure way. But
yeah.
If the misbehaving listener.
If the callback misbehaves,
yes,
we might catch it here, depending on the semantics of the executor.
We don't really care about it.
Yeah, we care about it because we want to log it, but we don't want to act on it. Like there's no guarantee that we can provide that has to do with what the error handling semantics are. Okay, so this was execution list.
Why is it static, by the way?
I don't know. It's private, so it's once again it's a whatever.
Does this class have tests?
Have
Each of these classes have tests?
I don't know. I haven't actually looked.
I mean, it's interesting if Google Guava uses text.
I'm pretty sure it does. We can. You know what? Let's because we basically finished covering this class. Let's have a look at whether or not these things have tests, because I honestly don't know. And I'm gonna shut this up. To your question, yes, it does have tests.
And it's there are 2 guys actually. Nishant, probably someone from India.
And Sven. And Sven can be assumed to be a male person.
Nishant is probably a guy named Indians have
names. Okay. Okay, let's move on. Okay.
One more question, Tomer. What about the use of logarithm? What do you think about that?
The use of a logger?
Yeah.
The only concern I have here, like it makes sense. You want to be able to log this, right? The thing about this is you need to, as a library author, you need to make a judgment call as to which logging system you're going to use. So in this case, they use Java util logging directly. I would have probably just used SLF4J unless I had a really good reason not to, and just left the decision of, which logging backend to hook up to and how to deal with the logs to the library user, as opposed to making that decision myself. Why it's actually using Java util logging, I really couldn't say. One possibility is that, look, Guava is not a new library. Like, it's been around for probably 10 years, if not more. And this is one of the earlier aspects of Guava. So it's entirely possible that SLF4J just, it was around, but it might not have been, popular or production grade or whatever at that point.
Also, like you said earlier, they wanted to reduce the footprint, like the dependencies.
Yeah, but I mean, this is the only reason why that comment applies is because Java util logging is part of the Java class library. So it doesn't really reduce the footprint. It just means that the dependency is one you already have, whether you like it or not.
SLF4J someplace else?
In Guava, not to my knowledge, but I haven't looked.
I guess it's
I really haven't looked.
It's probably a library call.
Probably. I'm not. I don't know. Like, I haven't really looked. Okay. Any questions before we move on a bit? Okay. So we've covered execution list, which is what actually deals with the registration and execution of callbacks. We've dealt with Listenable Future task, which is the canonical implementation of a listenable feature. You'll note that nothing's to stop you from implementing a listenable feature on your own. As long as it maintains the same semantics, things are going to work. But you probably wouldn't want to. And finally, we have the next interesting thing here is, why does it keep closing my notes? Yeah, the next interesting thing here is going back to the listenable future thing is what the documentation says, if you recall, is this. If you want to take futures returned from an executor service, and you want to use a pre-existing executor service and get listenable futures, this is an extension. You want to be able to tack on this extra functionality to things you already have at play, which executors you almost by definition already have in your program somewhere. So what you do is you call more executors.listening decorator, you pass it a pre-existing executor service, and you get back a listening executor service. So let's head on to listening decorator, and let's just take a quick look at the signature before we actually dive into the details. It's a static method, obviously, and it takes a single parameter executor service, and it returns a listening executor service. So let's start off with this thing. What's a listening executor service? Well, obviously, it's just a variant of an executor service that provides you with listenable features as opposed to normal features. The curiosity here is, it's an interface. It doesn't have an implementation, and it overrides various methods in the normal executor service so that a listenable feature is returned. So we have the usual variants of submit, say submit that takes a callable task, and we override the base implementation to return a listenable feature instead of a normal feature. And we do this for just about anything. A curiosity is with regards to invoke all. So invoke all takes a bunch of callables and returns a corresponding list of features. Now you'll notice that even though we're looking at a listenable executor service, what it actually returns is a list of features and not a list of listenable futures. Anyone care to take a guess at why that is?
Because list is invalid.
Because list is invariant. Unfortunately, he's absolutely correct, and I honestly didn't expect anyone to notice that. Shit. Okay. So we have this. Okay. So Danny has. Yeah. He just basically screwed up my entire presentation. We have this invoke call in our executor service, and it returns a list future t. Now, actually, the beautiful thing is Danny is almost correct. List is not invariant because variance in Java is not a declaration level thing. It's not a type thing. List cannot be covariant, contravariant, or invariant because you don't have that semantics in Java. Variance in Java is at the use site. So what this means is if this original executor service dot invoke all returned a, well, I can't actually write here because it's source, but if it returned a question mark extends a future of t, returned a list of something that extends a future of t, then that would have been covariant, and I could have returned, I could have overridden it to return a listenable future of t, but it doesn't do that. So what this means is that there's absolutely no way for me to change the return value of my invoke all in a way that's compatible. So this is why instead of returning a list of listenable futures, I still return a list of futures, but I resolve this with documentation. Okay, the documentation for invoke all says executes yada yada yada, returning a list of futures yada yada yada. All elements in the return list must be listenable future instances. The easiest way to obtain a list is an unchecked but safe cast. Okay, and this is a limitation, combination of a limitation of the Java type system, because the list type, the list container cannot be made covariant, but it's also a limitation of the original library, because extending this thing would mean that, if I wanted to do this properly, I have to rely on the pre-existing interface called executor service to have a method that returns a list of something that extends a feature. And that's just not the case, so I'm screwed.
So it's bad design in the library.
It's
Standard library.
I don't know if it's bad because it's something that's pretty easy. Yeah, no one foresaw the use case for that sort of thing, and the type system does not enable it by design. So, yeah, I'm screwed basically. That's all I can do. I can guarantee it in the interface, in the documentation of the interface, but there's no way to make the compiler see this, see this extension and verify it. So that sucks, but that's all there is to it. Okay. Now, in terms of the actual implementation, so I have a listening decorator. It takes an executor service delegate, and then it wraps it with something that provides a listening executor service. So the first thing it does is it checks, was I already given a listening executor service? If I was, then there's nothing I need to do. I just need to cast it and return it, because otherwise I'm just tacking on a whole bunch of functionality that costs me performance and adds no value. The other option, and this is one thing I wanna, one point I wanna make is, Shai earlier on said that this, I think it was Shai, that this dude is a C programmer. I think this is a much better indication that that person was a C programmer, because trinary operators are horrible. Okay, this is what happens, and this is actually
chained together.
Yeah, and this is actually almost treatable. What you basically have here is an if else, no, it's if else, else if else, else. Okay, so it's pretty crappy. This would have been much nicer with a Scala pattern match, but you don't get that in Java. This would have been much more readable, I think, with chained if else statements, but you don't, you do get that in C, but you don't use that in C because you like your expressions to be unreadable. So, moving
I
on.
wonder if this guy still works at Google.
Probably, maybe, I don't know. Okay, so what I got is not a listening executor service, and there's two classes of executors in Java. There's a normal executor or executor service, and there's a scheduled one that also does scheduling of tasks. So we need to handle both of these cases, and these are, the way we do this is we have a scheduled listening decorator that takes a scheduled executor service, and a listening decorator that just takes an executor service. And we're going to cover these two in a little bit of detail. It's probably going to take something along the lines of 10, maybe 15 minutes, and we're done. So, if anyone is itching to go to the bathroom, you can either hold it in or, just go. So let's start with a simple case. Okay, we want to take an executor service and wrap it in a listening executor service that handles, handles listenable futures. So the listening decorator is a private static class. Okay, it's part of the more executors class that we're actually looking at right now. It extends an abstract listening executor service, which we'll cover in a second. It takes a delegate, and what it basically does is, for all of these public methods, it just implements them by routing them to the delegate service. So obviously the question is, where do the listening futures come in? Like, okay, fine. Well, I have this weird thing. Where does the extension code come in? So this is the abstract listening executor service, which extends an abstract executor service and implements a listening executor service. I'm not gonna bother you with the details of how the code is routed too much. What I'm gonna say is this. In my opinion, the problem with this code is that first of all, if you look at it, it just basically overrides a bunch of new task for runnable, new task for callable. It wraps it implements submit, returning a listenable future in various variants. So it's pretty straightforward. It basically just wires things together, right? The new task 4 gets a callable, it calls listenable future task.create, and that's the task that's returned. Whereas the abstract executor service is what actually calls listenable scheduled task for this task with the scheduled future. And a listenable scheduled task is, once again, a pretty stupid class. And I'm not going to go into the implementation because it's pretty stupid, but it extends a simple forwarding listenable feature, which is to say it takes a listenable feature and it forwards everything except what I explicitly override. And what's override is when I get canceled, okay, when my scheduled listenable feature gets canceled, I wanna cancel both the listener, the listening aspect of this feature and the scheduling aspect of this feature. These are two things that need to be taken into consideration. So I override cancel, I call super.cancel, which, given that I'm extending a forwarding listenable feature, which in turn extends a forwarding, I'm extending a simple forwarding, which in turn extends a forwarding, yada yada yada. The bottom line is this basically calls my delegated listening feature, okay, and it just cancels. And then I also cancel the scheduled task. I also override get delay by delegating it to my scheduled delegate, and same thing with comparative. So this is just basically a lot of boilerplate code that says I have this thing that's supposed to run, I have this thing that schedules this thing that's supposed to run, and I need to make sure that any operation that happens to me wrapping these two things gets delegated to both. Okay, so it's just a bunch of boilerplate and if statements and all that stuff. The other curious thing that happens is that if a task gets scheduled at a fixed rate, this is a bit odd. There's a never successful listenable future task, and this is a curiosity. Never success. I love the name of this class. This is the best named class I've ever run into. A never successful listenable future task. So it's an abstract feature. It's runnable. It's never successful. And what this means in practice is when run gets called, I delegate to whatever it is I'm wrapping. I catch exceptions, and if I get an exception, then I set it and then I throw it. Now, you might look at this. It's not a lot. Oh, sorry. It's not a lot of code, right? You might take a look at this, and you might say, okay, so why is this never successful? Like, there is nothing in this code that screams to me, this can't succeed.
It's probably
Okay, I would say this can succeed or it can fail. I'm sorry.
It doesn't call the API that's successful.
True, but because it implements runnable, it doesn't look like it has to, right? You don't expect it to have to explicitly say, I succeeded. And it took me a little while to dig into the code to figure out what the hell is going on here. And what happens is this thing extends an abstract feature, and an abstract feature at the bottom of the class hierarchy. The bottom line is this is actually implements or extends a future task.
They should should have like overridden the successful API.
You can't override the successful API because here's the thing. You're inheriting from a future task. Now, tying back to, I think, the first 10 minutes of the session, a future task is a cancelable feature. It's a state machine. And it can move from various states to the completion state. The thing about a state machine is that once you move to the completion state, that feature can, like the code that actually generates the result that moves the future task to the completion state can never run again because it's already completed. Okay, so why this is never successful is that
needs to run again.
you're supposed to, I'm sorry?
Because it needs to run again and again and again.
It needs to run again and again and again because it's scheduled at a fixed rate. But more importantly, the reason it's never successful is that a proper implementation of this would have something that looks a bit like this. Set value. And the value can be null or it can be 5 or whatever. This thing completes the future. Okay, so once again, the future API in Java is, you can see in essence just how antiquated it is, because a lot of what is nowadays considered to be good design for a future API just isn't here. Okay, a feature task is analogous to a composition of a feature and a promise. And this thing, what's selected right here is the promise API. Okay, I'm fulfilling a promise by calling set with a value or by completing with an exception. And when this isn't present, as is the case with the original implementation, I'm never fulfilling the promise, I'm never completing the future, so it can be scheduled again and again and again and again. And that is a hack. Okay, that's a terrible hack because it assumes 3 different things. It assumes that a future with its dual, okay, with its promise that has never been fulfilled can be triggered again and again and again. And that's an assumption that's, I haven't looked too deeply, but I don't think it's explicitly stated anywhere in the API. Okay, so it doesn't assume the presence of a desired behavior, it assumes the absence of an undesired behavior, which is terrible in my opinion. Second, there's no comment here that says why the thing, okay, why the fucking hell this thing can never succeed, because, this is never successful. Why is this never successful? This code looks perfectly sane to me. It looks like it's always successful, right? It doesn't look like it should be able to break unless an exception happened. So it's badly documented. And
if tomorrow someone changes something in the abstract future,
if someone changes the future API tomorrow, then it's it's essentially a breaking change. Right? The thing about this is that it codifies a hidden assumption, which is always a bad thing. So this is this whole it's just 1 o'clock. Okay, so I'm done. By the way. This is everything I wanted to cover. So for the last 90 minutes, we've basically covered a bunch of stuff that was aimed at reaching this bit of code here and showing just how shitty this code is. Okay, I couldn't have explained why this is shitty without all this 90 minutes of context. This is crap code. Okay, so don't ever do this.
And though the name is very nice.
Yeah, I love the name, I hate the implementation. Okay, so we're basically done. I hope you enjoyed it. Talk to me later. Like I'm not gonna hold you anymore. Other than to say that if anyone wants to run a session like this, then I'd be delighted. And B, if anyone has ideas for additional sessions like this, then I'd also be interested. And the next session can be in Scala.
Apache HTTP Client 4.
Don't get
That's the worst library ever written.